All right, now we're going to talk about normal lines. And the process for finding the equation for a normal line is actually the same as what we were doing for the tangent line. There's just one slight difference, and that is the definition of what a normal line is. See, the line that is normal to a curve at a point is simply the line that is perpendicular to the tangent line. So, if you have the tangent slope, right? So the tangent, let's go ahead and write out the whole word. The tangent slope, that always just equals f prime of whatever your x value is, right? Well, if you remember, your perpendicular slope, which we're going to call the normal slope, that's the negative reciprocal. So you're going to find your same derivative, and you're just going to stick it underneath -1, and there you go. You got your normal slope. That's all there is to finding the normal line. So these problems are all the same equations as the previous notes, but now we're just going to do the normal line instead of the tangent line. I do want to point out here that this is technically wrong, right? Because it's not dy over dx. If you were to think of it, it's a reciprocal. So you could think of it, let's cross it off. You could think of it as negative dx over dy. That's kind of a good way of thinking of it. But I think an easier way of thinking of it is exactly what I wrote here. It's just the negative reciprocal of the derivative. So let's just replace that with -1 over f prime of x1. And I think that's the easiest way to think about it. All right, so we actually already have our x1 and our y1. We just need the derivative, and then we're going to take the negative reciprocal of it. So, well, let's do the derivative real quick. Derivative of x is just 2x. And now we can say that the derivative of x1, which is 2 times 2, which is 4. And then finally we can go ahead and get our normal line slope, which is going to be the negative reciprocal. So this is -1 over 4. And so we're going to put it all together, and our equation is going to be y minus, our y1 is 5, equals, remember, instead of just the normal derivative here, we're going to take this, I'm sorry, the normal, I'm using normal twice. Instead of the standard derivative here, I'm going to take the normal line slope, which is the negative reciprocal. So I'm going to plug in a -1/4 x minus 2. Boom. There we go. We've got the equation of the normal line. All right, let's go to the next page. Okay, once again, we got a problem here for you to try out. Looking for the normal line. I want you to give it a shot. They give you the x1 and the y1, and they give you f of x. So remember that the normal line slope is going to be -1 over f prime of x. And you already have x1 and y1. So your equation to this normal line is going to be y minus y1 equals -1 over f prime of x times, oh, and that's f prime of x1, x minus x1. So give that a shot, and then unpause the video when you're ready to check your work. Okay, so I went ahead and took the derivative. I got 2x plus 2. Then I plugged in my x1, which was -3. 2 times -3 is -6, plus 2 is -4. So I want the negative reciprocal of -4, so that's -1 over that number, or -1 over -4, which becomes +1/4. So my slope is 1/4, and I plugged in y minus my y1, which was 4, equals 1/4, which is my normal line slope, times x minus -3, so that turns into +3. And so there's the equation of the normal line. All right, there's one more problem here. Again, I want you to try it on your own. Very similar to the problems on the previous notes, but now we're looking for the normal line slope. Remember, this one only gives you x1, so you still have to find y1 and, alright, here you need to find y1 and you need to find the normal line slope, which is going to be -1 over f prime of x1. So two things you have to find to write out that whole equation which I'm going to copy down one more time. All right, give it a shot. Pause the video when you're ready to check your work. All right, so you're going to find y1 just by plugging in x1 into the function. That's pretty easy. You get 8. Then you're going to take the derivative of 3x squared, plug in your 2, and you get 3 times 2 squared, which is 12. So that means that your normal line slope would be -1 over 12. So plug it all into the point slope form. You get y minus 8 equals -1 over 12 times x minus 2. That's all there is to it, folks. See you guys in the next video.